In section 4, we're going to take a look. Let's get our microphone working properly. We're going to take a look at slope and rate of change. And we'll build up and tie it into the formulas we've been looking at. So far we've been graphing lines, and then they describe that the line, when we look at its slant or steepness, we describe it as slope. And what slope is a ratio, which is a fraction, of vertical change, which is your y units, corresponding to horizontal change, which is your x unit. So, and we use the letter M to designate slope. So slope is the ratio of y units over x units, which we're going to say is rise, that would be vertical, over run, which would be horizontal. Okay? And we'll look at a particular example here. So there's a typical graph, and we have labeled 2 points on the graph, 1, 2, and 4, 6. And if we make a little right triangle, so to speak, that we're going to go over from 1 to 4, 3 units, or they can have it up here, 1, 2, 3, or rise 1, 2, 3, 4 units, we get our slope of this line going over 3, up 4. Now they've gone up 4, over 3. Either way, I have a tendency to do it this way, as you'll see later on. Now it makes no difference which 2 points you choose to do your slope, as long as they're crossing the grid, that is the lines of the graph. So they're on the grid lines. If they're off, then you can't use that point. And we'll see lots of practice here. Now there is a formula to describe this that we have called reference number formula 3, which is M equals, when you have 2 ordered pairs, x sub 1, comma, y sub 1, that will be one ordered pair, and another ordered pair, let's get the right number here, x sub 2, comma, y sub 2. So these are 2 ordered pairs anywhere along the line. Again, they have to be on the grid. That we then say M, or slope, is y sub 2, this y sub 2 over here, minus y sub 1, this one, over x sub 2 minus x sub 1. And that's what they have here. Okay? M is the lowercase letter we use to designate the slope. Now, what they're going to do is give us some problems now to work, and you'll have this in your math lab as well. And the ordered pair they're giving us is right here. So our M will equal y sub 2, which is -3, minus, that's part of the formula, the 5. And then you go to the second, y x sub 2, which is 2. Minus is in the formula. Now this is where it gets a little tricky, because it's minus, which is in the formula, a -1. So we're going to put that in a parenthesis so we don't get our signs messed up. Now what's going on here? Well, we have the opposite of a -1 is going to make this a positive. So now we have a -8 on top, and this is going to be a 3. So our slope of this is a -8/3. And if you were to graph it and count the units, you would end up with the same thing. All right, let's do a little practice here and do this one here as well. Now in the beginning, you probably have to write the formula down, but y sub 2 is 5 minus 11, which is your y sub 1, over x sub 2, which is 2 minus is in the formula, that this is a negative now. I could put it in -4, but I know it's now going to become a +4, because minus a minus makes that. So our numerator now becomes a -6. 5 minus 11 is -6 over 6. This slope will be a -1. Okay. Now they are saying it doesn't make a difference whether you designate these as the sub 1s or these as the sub 1s. It's just that you can't interchange them, pieces of it. If these are the sub 1s, these are the sub 2s, that's fine. Or you could switch them around, but try to stick with one thing so you get a modus operandi, a method of operation, a strategy to get the right answer. Now, where can you put the negative sign? Well, you could put it there as well, or you could put it up there. The usual place of putting it is by the division bar. Okay, and you'll be practicing. So here they want you to graph this after you find the slope. So we can just use their writing. They've set it up very well. And they get a -6 over -3, which is a +2. And on the graph, they plotted this, and they plotted that, and they made a line through it. Now let me do the practice for you, just to see another example done. So 1 minus a -1 gives you a +1. 3 minus a -3 gives you a +3. So that's 3 plus 3. So that gives you 2 over 6, which we always reduce to 1/3. And if you plot that point and that point, it'll make your nice graph. Okay. Now, let's see what they did here, because these are a little bit fun here. So 6 minus 5. All right, they're doing it backwards. I always do it this way. A negative 2 and a negative 3. So this is going to be a 1 over negative 5. So I don't know what they did here. They did... I see. They're taking a piece of 1 and they're reversing them. So you can't do it this way. All right, that's what they've done. I told you that you can't take a piece of 1 and then switch it around. You have to stay with the, if this is the sub 1s, these are the sub 2s. And what they did is they took a piece of this and put it over there. So they got the wrong answer. So be careful. All right. All right, now they're giving us another helpful hint here that anytime your graph ends up looking like this, that is, it starts high at the left, and as it goes to the right, goes down. This is negative slope. Anytime it starts low, and as you go to the right, goes up, this is positive slope. So somewhere in your notes, you should write this. And this is after you graph something. If you see that it has negative slope in your equation and your graph looks like this, you know it's wrong. And vice versa. If it's positive slope and you see your graph looks like this, then it's wrong. Okay. Now, we're going to take a closer look at some of these equations here. And this is our famous equation that we use reference number 2, y equals mx plus b. Now, we had said that this was our y-intercept. That is, when you graph this equation, it's going to go through the y-axis at this point. But notice now we see the letter m in that formula. In fact, this equation is called slope-intercept form. So we see it right here. So what can we say about this 2? Well, that's going to be the y-intercept. And what can we say about this 3? That's the slope. So we're going to show you at this time there is an easy way to graph these. Instead of making a t-chart, we can just plot our y-intercept. We know it's going to cross the line at 2. So we put a dot at 2. And we know our slope is a ratio of y units over x units. And so this slope is going to be 3 over 1. And this is rise over run. Now here, I'm going to show you how I do it. You could do it your way too. You want to be sure you get the right answer. So I look at the slope. Is it positive? Yes. So I'm going to plot the run units. So from my y-intercept, I'm going to go over 1. That's my run. And I do this mentally on MATLAB. and then it's a rise of 3 from that point. So now I go up 3. 1, 2, 3, and these correspond to units over there. And then I take my line, and there's my graph. Wow! I didn't have to make a T-chart, no. And what technique did I use? Well, I knew the y-intercept from this formula was 2. I put a dot at 2. I then looked at the slope and saw it was 3, which I know now is 3 over 1, which is 3 rise units over 1 run unit. Now, just to show you that there are other ways to do this, you could have gone rise first and then run. You get to that same second point, and it's just a matter of technique. You can use either one. Now from this point you can go over 1, up 3 again to get there. Or you could go down 3 over 1 to get there. Again, there's lots of little right triangles all over the place. And in Math Lab, again, just 2 points will do it, because that's what you need to fix your second point to get the line. Okay. So here they're introducing again the slope-intercept form, where there's the standard way to write the y-intercept. So whatever is in the numerical coefficient of x, back from chapter 2, that is your slope. And whatever's out here is your y-intercept. If there's nothing out there, the y-intercept is 0. It goes through the origin. So let's graph example 3. Well, perhaps I should read the question first. They don't want you to graph it yet. They want you to find the slope and the y-intercept. Well, when it's set up in y equals mx plus b, our y-intercept is this, which we write as 0, 6, and our slope is the numerical coefficient of x, which is 3/4. Now, even though they don't want us to graph it yet, I'm going to show you how easy it is to graph it. Our slope is 6. 1, 2, 3, 4, 5, 6. And again, we're just sketching here. And our slope is 3/4. So I'm going to go a run of 4. 1, 2, 3, 4. A rise of 3. 1, 2, 3. And this is what you do. You put your dot on the y-intercept, then kind of go over 4 mentally, up 3, put your other dot there, and then the beauty of Math Lab, they make your graph. Wow. No T-chart, just graphing from this. And for this one, the y-intercept is 0, -2. The slope is 2/3. Now, a little twist on this is, suppose your equation looks like example 4, where you have a negative y equals 5x minus 2. Well, remember, in order to pick the slope and y-intercept out of this equation, you must have a positive y. So for something like this, just divide everything by a negative 1, and it just changes all the signs. So this now becomes a positive y, this becomes a negative 5x, and this becomes a positive 2. So now there is your slope, and your y-intercept is 0, 2. Okay? And the same thing down here. This would become a positive, this would become a positive, this would become a negative. Okay. Now, moving on to example 5. Now, we see an equation that looks like this. 3x minus 4y equals 4. This is in standard form. So how can we pick out the y-intercept and the slope when it's in standard form? Well, the answer is you solve for a positive y. Transpose the 4. Again, I just transposed the negative 4y, made it a positive on this side. Now I'm going to divide everything by 4. And then I could rewrite it this way too. Y, this is y over here, equals 3/4 x minus 1. So my slope is this, and my y-intercept is this. Okay? Now they did it the other way. They transposed the 3x, got it to be negative. Then they divided everything by a negative 4. Remember I told you there is a problem that students can sometimes forget to put negatives there. So if you make your y positive first, you don't have to worry about it. But this way's a good way too. It's just that it's more prone to error. Okay, now here are some special cases where we have the equation. See if you know this equation here. It's a horizontal line. This is y equals negative 1. Now, if you picked any 2 points along there and put it into the slope formula, it would end up being zero divided by a non-zero number, which would be 0. So we're going to say from now on, anytime you see this equation or a horizontal line, the slope of a horizontal line is 0. Now you could work it out, but there is a statement. So what's the slope of this? It's a horizontal line. It's going to be 0. And here they tell you the slope of all horizontal lines is 0. So that leaves us what would be the slope of a vertical line. And again, this was that special formula that we referenced as formula 6, x equals a. This is going to be a vertical line going through 5 here. Now, if you put any 2 points into your slope formula, you end up with something unusual. That is, your denominator is 0. We said we couldn't have that. So from now on, anytime you see a vertical line, the slope of a vertical line will be undefined. Remember, the slope of a horizontal line is 0. The slope of a vertical line is undefined. And there it is right there. And there it is right there. So again, on that index card, and actually I have a little summary on one of my other videos of the formulas you should be familiar with for Chapter 3. So here's a little summary of slopes. Again, a very useful aid for remembering things. If it starts low and goes up, this is positive slope. If it starts high and goes down, it's negative slope. If it's a horizontal line, 0 slope. If it's vertical line, it's undefined. We don't use this no slope very much. I stay away from it, because no slope kind of reminds you of 0 slope, and that's not good. So horizontal line, 0 slopes. Vertical line, undefined. Okay, now something again we mentioned very, very briefly in the earlier topic. We said, how about slopes of lines that are parallel? Well, we had given you reference equations 7, that if m sub 1 equals m sub 2, that is, if your slopes are the same, but your y-intercepts do not equal each other, we say the lines are parallel. This is symbol for a line, and this is symbol for parallel. Now we also have mentioned, or we will mention, in Formula 8, if m, let's put the right letter down here, if you multiply your first slope by your second slope, and the product of these slopes is a -1, that is, if you had 1/2, and you're multiplying that by a -2/1, it's negative reciprocal, that's going to be a -1. We say the lines are going to be perpendicular. So this is just a little study aid to help you determine whether you are dealing with parallel lines or perpendicular lines. And you'll be needing this skill as we move on. So here we see this line as a -2 slope, and this line as a -2 slope. So the slopes are the same. But as we look at our y-intercepts, they are different. And remember, we said this was shifted up this much in an earlier lesson. It would be like 7 units. Anyway, looking at that, what does it tell you? The lines are parallel. And notice they're negative, so they're starting high, going down. And that's that. Those are parallel lines. And you might say, well, how do you determine this? And here they're introducing perpendicular too. So we'll get to that here on this next page. So how do we know lines are perpendicular? Well, again, if we compare their slopes. So we look at this slope, and that slope is 4, and this slope is a -1/4. And if we multiply them, remember this is 4/1, so this is the negative reciprocal of that. The product of this will be a -1. That's why we know They are perpendicular. Okay? That is, there's a right angle where the lines cross each other. Now, let's get to some examples here. Oh, let's look at this too a little bit. I see this here. Two distinct vertical lines are parallel. Two distinct horizontal lines are parallel. A horizontal line and a vertical line are always perpendicular. Just a little study aid here. Okay, example 8 is what you will find in Math Lab and on your practice in Quiz Me is determine whether each pair of lines is parallel, perpendicular, or neither. And you look at them and you say, wow, how could I do that? Well, the key is you have to solve each equation for y. You might say, why do you have to do that? Well, because then you can compare the slopes. So for this one, we have to solve this equation. It's 10y equals, I'm going to transpose this 2x to the other side as a negative 2x plus 3. I then divide everything by 10. And I now get y by itself, which is what I want, is equal. Now as I reduce this becomes a negative 1/5 x plus 3/10. Now we don't care, well, we care a little bit about this. We basically want to look at the slopes. Well, this slope is a negative 1/5. This slope is a negative 1/5. Are the slopes the same? Yes. Now here the y-intercept is 1. Here the y-intercept is 3/10. Are they parallel, perpendicular, or neither? Same slopes, different y-intercepts. These are parallel. And that's what you need to do for each of these. Solve it carefully for y. Let me do b for you here as well. So this is going to be y equals over here. Transpose the x, that's a negative x plus 3. And then I give this next one is y. There's my y. Transpose the x. This becomes now a positive x plus 4. Now, what's the slope of this? 1. What's the slope of this? Well, negative 1 here. 1. Negative 1 times negative 1. Let's say that again. Negative 1 times a positive 1 is negative 1. So this is perpendicular. How did I know? I solved for a positive y, compared my slopes, multiplied them together, got a negative 1, indicates they are perpendicular. And we'll do this one right here. Y equals a negative 3x plus 5. This is going to be 3y equals a negative 2x. Ooh. Trying to go too fast here. 2x plus 6. Now, I divide everything by 3. I get y equals a negative 2/3 x plus 2. Well, here my slope is negative 3. My slope here is negative 2/3. They're not the same. They don't result in a negative 1 when I multiply them. So this would be neither. Okay. And the work is all here as well. So this is a parallel, this is a perpendicular, and the last one is neither. Okay. Next objective is slope as a rate of change. Again, it's a ratio of rise over run. And here they want to give it as a percentage. So here we have a run of 10 feet, a rise of 7, which gives us a slope or pitch of 7/10, which converted to a percent would be 70%. Here we have 100 feet, rise of 7 feet, 7 over 100, 7%. And these are some of the things you'll be doing. Find the grade of the road. Again, just put that in your calculator. 15 divided by this is 0.06, 6%. Now, finding the slope of a line in which you have two sets of data. Well, you are going to put that into a slope formula. This is your x sub 2, y sub 2, x sub 1, y sub 1. Okay? And you get this over this, which is 17 over 1. So we usually say your slope is 17. And they have some more graphing calculator work. And that will wrap this up. This is sort of a long one. I feel bad about that, but again, hopefully you have some good stuff to work with.